Salam and welcome everyone. So today we're going to be working on the question on the screen that says calculate the change in molar Gibbs energy of a perfect gas when its pressure is increased isothermally from 50.0 kilopascal to 100.0 kilopascal at 500 Kelvin. So the first thing we have to do is for us to write out the parameters. So I'm going to reread this and write that out. We're told to calculate the change in molar Gibbs energy. So what this is telling us to do is for us to determine the change in molar Gibbs energy. So that's what we're going to be solving for and of a perfect gas. So this is a perfect gas question when its pressure is increased. So that means we have increased isothermally. So that means we have an initial pressure and a final pressure because of the pressure increase. So from 50.0 kilopascal and then to the final pressure, which is 100.0 kilopascal at 500 Kelvin. So the temperature is 500 Kelvin. So I wanted to quickly mention that this is an isothermal question where there's a pressure increase. So the change in temperature is zero, or basically the temperature is constant throughout the entire process. So in an isothermal question where we're supposed to calculate the change in Gibbs energy or the change in molar Gibbs energy, the formula we're supposed to be using is this one right here, which is the molar Gibbs energy at the final pressure, okay, is equal to the molar Gibbs energy at the initial pressure, okay, plus RT ln the P final divided by the P initial. So the molar Gibbs energy at final pressure equals to the molar Gibbs energy at the initial pressure plus the gas constant times temperature times ln P final divided by P initial. So how you would get this, how we're going to have to rewrite this formula to be able to equate it to the molar Gibbs energy. So this is just going to look like the molar Gibbs energy of the final pressure at the final pressure minus the molar Gibbs energy at the initial pressure is actually going to be RT ln P final, okay, divided by P initial. So that would just be the change in the molar Gibbs energy, okay, equals to RT ln P final divided by P initial. So that's basically how this is done. Now, the next thing you have to do is just basic math. We're just simply supposed to substitute. So the change in molar Gibbs energy is just going to be RT. So R is going to be the 8.3145 joule per mole Kelvin. Now, I wanted to quickly mention something. You already know that we have two different values for gas constant. We have the 0.08206 as well as 8.3145. We're going to be using the 8.3145 because the unit for change in Gibbs energy or just any energy unit is in joules. So we're looking for the change in molar Gibbs energy. So what we're actually supposed to have is our answer in joule per mole or kilojoules per mole. So we have to use the units of the gas constant where it's gonna actually match the actual unit we're supposed to get for the answer. So that's why we cannot use 0.08206 because that's not the gas constant that I use whenever you're trying to get the energy unit. So that's why we're going to be using this one times the temperature. We know that to be 500 Kelvin. Okay, times ln the P final. We know that to be 100.0 kilopascal divided by P initial, which is 50.0 kilopascal. So, of course, we cancel out the Kelvin, cancel out the Kelvin, cancel out kilopascal, cancel out kilopascal. So, what is going to end up happening is this. We're just going to input this information in our calculator where we have 8.3145 joule per mole times 500 times ln 100 divided by 50. We can actually just cancel this out. 50 here, 1, 50 here, 2. So let me say that again. We're going to be putting this information in a calculator, 8.3145 joule per mole times 500 times ln 2. And when we input that information in our calculator, we end up getting 2,801.586 joule per mole. And that's basically the answer to this question. But of course, because we are chemists and in chemistry, there are laws and there are just better ways to us to manage our question. The first thing we have to notice is this. We have our answer in joule per mole, which is actually correct. But because of we're dealing with Gibbs energy, just like when we dealt with enthalpy, we like our work in kilojoules per mole rather than in joules per mole. So what's going to happen is we're going to go from joules per mole to kilojoules per mole. And we have 1000 joules equals 1 kilojoule. So to go from joules per mole to kilojoules per mole, we're just going to divide by 1000. So the change in molar Gibbs energy becomes 2.881,586 kilojoule per mole. Now, we're still not done, right? We're still not done because we're also chemists and we like to make sure we have the proper number of significant figures for our final answer. So we go back to our work. We have 50 point zero kilopascal. This is three sig figs. Okay, we've got 100.0 kilopascal. This is four sig figs, and we have 500 Kelvin, which is three sig figs. The rule in chemistry is that we're going to pick the lowest number of significant figures based on the information we're given in our question, and we're going to use that to determine the number of sig figs for our answer. So we have to actually do this in three sig figs. So we're going to stop here. So rewriting this, what we actually have is our final answer is going to be changing molar Gibbs energy. It's actually 2.88 kilojoule per mole. So that's basically how you answer this particular question. If you have any question, please put in the comment section. If you have any concerns as well as suggestions for topics I should cover on this channel, or if you have a particular question you want me to solve, make sure you put in the comment section. If you're a student who is struggling or who would like to improve to be the best version of yourself in all your STEM related courses, make sure you email me at shohabitutoring@gmail.com. I help students in middle school, high school, and college level to realize their dreams to become better students of STEM and better learners of STEM. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.